So I'm going to quickly explain some of the research I've been doing on autonomous agents for security operations, what I think some of you might find interesting. So I'll start by running the code and a prompt will come up for me to input a query. This is the last bit of human interaction in this flow. So in this prompt I'll put in a straightforward question like, what DNS servers are there and are any of these suspicious? As you can see, the LLM now constructs a Splunk query and then executes it itself, which you can see there on the assistant to user proxy. It's loaded a Splunk function, is now executing that Splunk query and will return the results. And you can see the first query returned no results, and that's because the model got the field name wrong. For the destination IP. Here it's assumed the destination IP for this source type is in field DNS resolving IP, whereas actually it's not. It's in dest_IP. So what it's done next, it's decided to explore the source type a bit broader and has just done a search looking for the index and source type. Now, important to note here is it's decided to do this entirely autonomously. There has been no human interaction since the initial prompt. It's a much bigger search. It's going to take a while to complete. I'll just do a quick note on the timings here. The reason why the LLM responses are showing up so quick is because they're cached to save my prompt token budget with OpenAI. The system caches the responses to the same prompts. So that's why that's responding so quickly. The Splunk query now, as you can see, is taking quite a while to execute. And now it's just completed the Splunk query. The response was long, so I've set it to return a JSON telling me the statistical properties of each field if the query is over 100 rows. This minimizes excessive token usage for the API. And from this, the agent has figured out the correct field name and then constructed a new query, which is now executing. And as we can see, it's returned a correct list of all the DNS servers used in this dataset. That is quite a lot, and probably more than I'd expect to have seen in an enterprise network, which is interesting. I hadn't explored this dataset before giving it that prompt. From that data, we can see the agent has constructed a more succinct query to look for the top 10 DNS servers. It's excluded 8.8.8.8 and 4.4.4, which I didn't tell it to do, so that's quite interesting. It's known that they are Google IP addresses. And then it's given me a quick text summary explaining the output and giving me a list of DNS servers to investigate further. Now I think that's pretty good for a first go. Bearing in mind my only human input there was the initial query of what DNS servers are used and are any of them suspicious. So I think that text it's given me there as the final output I'm pretty pleased with. So what now? Let's try something a bit more complicated. So I'm going to run the code again, but this time I'm going to give it a more complex prompt. Can you find any evidence of DNS tunneling? So I've not explicitly told the agent what DNS tunneling actually is, but as you can see from the first response, it has a reasonably good understanding of what this is and has come up with a reasonable strategy for how to find this. Now, you'll notice this time that it's started by exploring the fields. This is actually a change I made to one of the system messages to try and encourage it to do this, because it was always assuming that all the fields were correctly passed and SIM compliant. Now, that's not always the case in some of these data sets, so I've tried to encourage it to explore the fields first before committing to a complex search. Probably more representative of how a human analyst would use Splunk. You can see here it's returned a list of all the available fields and then constructed its next query based on that data. What it's caught here is the query field should just be called query for SIM compliance, but in this data set it's actually got the squiggly brackets afterwards, and this has managed to catch that and has now constructed the query correctly with the correct query name field. And its final query, which is now executing, does look like it has satisfied its initial plan of how it's going to look for DNS tunneling. I think that's a reasonable strategy for how to do so. So it's returned out its final output text here, which has said it has not found any evidence of DNS tunneling. So it has successfully executed its initial strategy, and I think based on its initial strategy, that is a reasonable conclusion to draw from this dataset. I had not explored this dataset to look if there was or was not evidence of DNS tunneling before giving the system that query. So I went onto Splunk to execute a manual query to look for the number of subdomains and the count of each. And as you can see, the agent was correct in its assessment.